Hi guys, welcome to PyMath. In today's video, we're going to be looking at a problem that deals with combination and geometric progression. So the problem is, what is the sum of all possible divisors for 4800? Before we get started on this problem, let's review the geometric progression sum formula. So let's quickly revise how to derive and how to remember the formula. So I'm going to pull up a standard geometric progression. It is Sn equals to a plus ar squared plus ar cubed all the way up until ar to the power of n minus 1. Then I'm going to pull up another one, and what we're going to do is we're going to multiply r to this series, and the new series r times Sn equals to ar plus ar squared plus ar cubed plus ar to the power of 4 all the way up until ar to the power of n. And what we're going to do is we're going to label this 2 and this 1. So this is going to be series 2, this is going to be series 1. And what we're going to do is we're going to subtract series 1 from series 2, or 2 minus 1, or Rsn, which is this, 2 minus Sn, which is this, 1. And when you do this, you'll find out every term gets cancelled out except for this term, because Rsn doesn't have it, everything is multiplied by r, and the last term of Rsn, because normal Sn doesn't have it. So since you're subtracting this from this, you get ar to the power of n minus a. And what we're going to do for this side of the equation, we're going to take out the Sn from both terms. And on this side of the equation, we're going to take out the a from both terms. And when we do this, we get Sn r minus 1, because we've taken out Sn from both the terms in this expression. And we get a times r to the power of n minus 1, because we've taken out a from both terms of this expression. And that gives us the formula. When you move this down, you get Sn equals to a times r to the power of n minus 1 over r minus 1. And that's the sum of geometric progressions. That's the formula, and that's how you prove it. Now let's go back to the original problem. What is the sum of all possible divisors for 4800? So let's prime factorize to find all the possible divisors. And when we prime factorize, we get 3 times 2 squared times 2 squared times 5 squared times 2 squared, or simply 2 to the power of 6 times 3 times 5. That's 4800 prime factorized. And first, let's find out how many combinations of the prime factors will give us all possible divisors. So we need to find out all the combinations of these prime factors and that will give us all possible divisors. So now let's find out how many 7 possible exponents of 2 there are. And there are 7, because you have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, or 2 to the power 6. So 7 possible exponents of 2. Similarly, there are 2 possible exponents of 3 and 3 possible exponents of 5. And when you multiply 7 times 2 times 3, you get 42. So there are 42 possible divisors for 4800. Now let's find the sum of all divisors. So what we do is we use the geometric progression formula. So 2 to the power of 7 minus 1 over 2 minus 1 times 3 to the power 3 squared minus 1 over 3 minus 1 times 5 cubed minus 1 over 5 minus 1. And in this scenario, we're basically taking r as this number, the number here, the number here, and the number here. So 2, 3, and 5 for each of the geometric progressions. And the n number is the amount of possible exponents they have. So for 2, as we said before, it's 7. For 3, it's 2. And For 5, it's 3. Okay? So when we multiply all these 3, we get 15,748. So 15,748. That's the sum of all possible divisors for 4,800. So remember, when you're calculating problems like this, whether it's on a math contest or just a regular school test, remember to use these formulas to help you solve. Okay? And 15,748 is the sum of all possible divisors for 4,800. Thank you guys for watching, and I will see you next time. And please subscribe if you enjoyed.